Hey you guys, it's Miss Arneson, and I'm here making this video for Science 232 Lesson 4 about controlled experiments. This is something that is really extremely important to all science disciplines, and it's something that you should be using and referring to in all of your science classes, so I hope this isn't the first time you've heard about it. But if it is, let's make sure we can clear it up for you. This page of notes, you do not have to write everything down that I have listed on the page. I do want you to write some stuff down, like where the lines are. So right here after the word hypotheses, there's a line. That means I want you to write down hypothesis and what is on that line. I'll kind of tell you as we go along so that you don't miss anything. But you also have this online, and of course you can use all of these things when you're taking your exam and doing your projects. So controlled experiments are really important in science because there's so many different causes and effects in every condition, every lab experiment that you have to really zoom in and you have to control and you have to be precise about what you're actually testing. A real life example of this could be like, let's say that you have a lot of acne and you decide that you're going to try out the Proactiv system. So let's say that you buy the system. It's got 4 different things like a cleanser, a moisturizer, a toner, and a pimple cream. All right. And if you start all of those products at the same time, and your acne is going away, but your skin is getting really, really dried out and you're getting a rash in some areas, it's getting peely, you don't know which one of those 4 things is helping you and which one's causing you problems. So instead of trying the whole thing at once, what I would suggest doing from a scientific perspective, and this is what I do on my own face because I don't want to have a weird pimple pop up, is you just use the cleanser first. So do what you've been doing, but use the cleanser. If the cleanser isn't doing anything good or bad, it's not causing anything, then you could decide to keep using it because you already bought it, or you could go back to a cheaper option. Then try the moisturizer, see what happens with the moisturizer. And just take those things one at a time. That's basically a controlled experiment right there. You're only changing one variable because that way you can actually measure what's happening. And in this case, the variable would be the part of the system, so the moisturizer, the face wash, the cream, or the toner. And the dependent variable would be the amount of acne on your face. You're trying to get rid of that without having a whole bunch of other stuff going on. So you do this in real life, but in science, it's really important that we do it because otherwise we can't have valid data. And in real life, if you are going to go into any sort of science field, you would not be able to have your work stand up to peer review if you weren't following these processes. So it's like the scientific method. You know how you learned about making an observation, then learning about what that is, doing research, asking a question about it, and then you have to set up an experiment, develop a hypothesis, do the experiment. Then you want to look at your data analysis after you've collected data and finally write a conclusion. So that's like a long process, but the hypothesis really will help you with everything else about a controlled experiment. So that's why I love coming up with them. So a hypothesis is a statement about what you think will happen in the experiment and why. A statement about what you think will happen in the experiment and why. So I kind of have heard like a hypothesis is a guess or it's like a question, but guess to me is like when you're on a game show and you guess an answer because you don't know it and you're just coming up with something off the top of your head. So it's more complicated than that when we're talking about a hypothesis. You have to have true background knowledge. You need to know a lot of scientific information about what you're talking about to make a good hypothesis. And here's why. Because there are 3 things that have to go in a hypothesis. Some mention of the independent variable, some mention of the dependent variable, and then some part that is science. And this is what takes our experiment about our face, like if we were doing Proactiv, to a new level. If we were going to make a formal hypothesis about it and do an experiment on our face, we'd have to have a because science reason for thinking that certain products would be helpful or not. And so that would require you to do a little more research about like pH of products and what are the ingredients and stuff, which I do because I am a science nerd, so I know all about everything I put on my face. But anyways, back to the trusty formula. This is the short version that I put, and I actually should have put it first, so you could write it down first. So the trusty formula for writing a hypothesis, it's not the only way to do it, but it will make sure that you do it right, is that you're going to have to say if, and then something about the independent variable, then something about the dependent variable, because of some kind of science reason. And I wrote out this long version too. If something about the independent variable is changed, then something about the dependent variable will change because of some scientific reason that you think it's going to happen. So there has to be a connection there. In the warm-up for this class, I had you guys guess about what you thought would happen with different plant lights. Like, how would you set up an experiment? A lot of people probably would think if green light, so that would be their independent variable, is is given to a plant, then it will grow more because plants are green, right? Like you could put that down. But if you knew anything, if you had background knowledge about wavelengths of light and also how plants absorb light for photosynthesis, you probably would not choose green light. You'd probably say if green light is shown upon a plant, then the plant will die because plants do not absorb green light, they reflect it. And so that would be a really good scientific hypothesis. In this class, I will give you the background information that you need to make a good hypothesis because we don't really have time online to go and do a whole bunch of research about it. In real life, I'd give you some research days, but in this COVID world where you only have to do a certain percentage of the work you would have to do in class, I can't have you guys do that. All right, let's look at so that's the hypothesis. It has to have these 3 parts. You have to put them in this order, and we're going to make one in a second so that you can see how it works. Parts of the experiment. So these are things that you're going to have to think about when you're setting up an experiment. So I'm going to give you guys an example today. How much water is ideal for spinach plant growth? So if you had to set up an experiment for that, you'd be thinking like, okay, well, I need to have some spinach plants. It would be good if the spinach plants are all the same size because then I can measure like if they grow better or worse. Some of them we would have to give a little bit of water. Some of them we'd have to give a lot of water. What else do plants need? They need light, so we have to make sure there's a light source. So you'd be thinking about how to put this together. How long are you going to let the plant grow? And that's actually all these parts of the experiment right here. So we'll talk about those and then we'll see what it would look like in real life. Okay, the research question is basically going to be answered by your hypothesis. So I'll give you a research question today for your lesson, but in the future, you're going to have to kind of come up with these on your own. So pay close attention to how this question is going to be related to the hypothesis that we make in a second, because we're going to make one. All right, the trials. Here's what I want you to write down for, for research question, here's the definition of that. The question you are trying to answer with your experiment. Okay, the trial is a run of the experiment. So like, let's say we were trying to see like if we change the angle of a ramp, how far will a bowling ball roll just from being dropped? Then we would want to have like a really low angle, a medium angle, a high angle. So that would be how we're changing it. And then we would measure how far the bowling ball is rolling. But we're changing this part, the angle of the ramp. So that would be our trial. Every time we let that go down, every time we let the ball go down and measure it, that's a trial, okay? A trial of the experiment is letting it run one time. In this experiment, we're going to be doing plants. So we're going to grow plants and we're going to have 3 different pots, and each one of those pots is going to be considered a trial of the experiment. So you want to have always at least 3 trials. In science, you do it a bunch more times, like you'd have to replicate it a gajillion, not gajillion, but a lot of times in order to call it real science. You'd have to be able to replicate it a bunch of times. In class, we usually only have time for 3 trials. Okay, variables. Variables are parts or conditions of your experiment. Parts or conditions of your experiment. So conditions means like if we're growing plants, like we have to put them in a room together and have them the same temperature, or we have to make sure we're exposing them to the same amount of light. We'd have to keep all of those variables the same so that we can test what we're actually wanting to test, which in this case is going to be the water amount and the spinach plant growth. So constants, these are also called, I hate that they're called this because it confuses students and adults alike. They're also called control variables. But these variables right here, the constants, and here's what I want you to write down for this. I should have put lines there. Okay, so just pretend like there's lines there. Constants are the variables that are the same in every trial. Constant means the same. So these are going to be the variables that are the same in every single trial. All right, now we're going to get to the more, I don't know, intentional parts of our experiment, the independent and the dependent variables. This is not going to be a very scientific definition that I'm going to give you, but it's the best one that I've ever found for helping students remember. The independent variable is the one you change. Okay, so you're going to change it on purpose before you take any measurements. The dependent variable is the one you're going to measure after the experiment is done. So the dependent variable is the one to measure after the experiment is done. And the way I remember that is because I'm going to do the experiment, and that's the independent part. And then the dependent part is when we're done. So it goes independent is the one I'm going to change before, and then the one I'm going to measure when I'm done, which is the dependent variable, like D done, is the one the dependent variable, the one that you're going to measure. Okay, the control, and this is why I hate that people say control variables, because the control is a totally different part of the experiment. The control is the trial with no independent variable added. The trial with no independent variable added is going to be our, wait, I think I just said control with no independent variable. It's the trial. The trial with no independent variable. Basically, it's there to make sure you don't mess up. So in this example, we're going to be watering plants. One of our plants, we're not going to water it because we expect for it to die. If we're saying water is helping them grow, if that one that we don't water doesn't die, then we would have to be like, is there somebody sneaking in giving water to the plants? Is there a leak above this plant? It's there to make sure that we didn't mess up. So for example, in the COVID, they're doing COVID experiments right now for people to see if the vaccine works. There are people who are considered the control. They are not getting the vaccine. You have to measure if them not getting the vaccine is going to make them at higher risk for catching the virus, and the people who are makes them less at risk. And so there's controls in experiments, even so sometimes those are people. Crazy. Okay, let's do a little practice. So in this one, I'm going to give you the research question. How much water is ideal for spinach plants? Okay, so what we're dealing with is water. So the amount of water that we give our plant and the amount that it's growing, right? How much water is ideal for spinach plants? That's how we're going to measure the spinach plant's growth, is to see if the amount of water, us changing it, will change the amount the spinach plant grows. So here's our parts of the experiment. And I always think it's really important to try to figure out your independent and your dependent variable first, because then you can figure out what all the constants are, and that's going to be easy. So what are we going to change? What am I going to personally change in this experiment? You can think about it for a second, pause. I'm going to change the amount of water. So I'm going to put the amount of water here. You could also put something like milliliters of water. So when I'm telling you to make a hypothesis, there's bunches of ways to phrase it, and it just depends on your preference and your skill level. The dependent variable, what am I going to measure? Well, I'm trying to figure out what's ideal for spinach plants. Spinach are plants, so they should grow. How can I count growth? There's a couple of ways I could do it. I could see how tall the plants get, so measure how tall they get. But what if they grow like kind of sideways? Like then I wouldn't really get information for that. So what I'm going to do instead is I'm going to choose to measure the amount of leaves on the plant. Okay, if I measure the amount of leaves on the plant at the beginning, then I should be getting more and more as it grows. So what are going to be a constants? Well, what do you need? You need light. So let's do 8 hours of light. What else do we need? We're going to have pots for them to grow in. We need identical pots. We need some carbon dioxide in the air. So we're going to make sure the air is all going to be in the same room. So we're going to put all of these plants in the same room because air actually has a bunch of parts of it. How much carbon dioxide is in the air, how much oxygen is in the air, what temperature is the air. So if we put them all in the same room, then we'll be controlling for some errors that we could have if we put them in different rooms. So the air is going to be a constant. We need to use the same type of soil in every single pot, because if one has fertilizer and one doesn't, that could be the thing making the plants grow. We're also going to measure for time. So let's say we're going to measure these over 5 weeks, because spinach grows pretty fast once you get it started. So if we already have a spinach plant, it's going to grow pretty fast. So we'll do this for 5 weeks. We're going to measure it at the end of 5 weeks. And those are going to be our constants. If we really wanted to, there could be a lot more constants than that. We could get like really super specific and be like the type of fertilizer in the soil. We'd need to measure the soil, right? We'd have to put, I don't know, certain amount of grams of soil in each one of our pots. So that is going to be a long list. The constants list can get really long, but there's a lot of variables that you have to consider when you're setting up a controlled experiment. So let's go ahead and build our hypothesis. All right, you don't know very much background information maybe on like the particulars of photosynthesis, but you know that plants need water to grow, because like if you don't water them, they die, right? So you've seen that throughout your whole life. So we're going to use that as our science reason. So here's what we need to do. We already identified our independent and dependent variable, and we basically, in our mind, we built this experiment. Now we're going to write our hypothesis so that it can be tested. So we're going to say if, because that's always the first part. Oops, got to capitalize. If, and then we can't just say if the amount of water, then the amount of leaves, because that doesn't make sense. So we have to do some like sentence structuring here. We have to come up with some words. So that's why I left this trusty long formula version here for you. So if something about the independent variable is changed. So here's where we could have a class of 25 people and every single one of you could come up with a different hypothesis. All of them are correct because you can style this in a variety of ways. So we could say if more water is added to a spinach plant, if the amount of water given to a spinach plant is higher, if this many milliliters of if increments of milliliters of water are provided to a spinach plant. Like you could say this a bunch of different ways. You could also say if the amount of water given to a spinach plant is less. So you can choose words like more or less or increased or decreased. I'm going to use increase and decrease for the most part because those are like the more sciencey sounding ones. So I'm going to say if a spinach plant is given increased amounts of water. Okay, so that's my if. Well, what do I think is going to happen if I give my spinach plants more water? Do I think they're going to grow more or less? Well, I'm going to go with more because then they have more water to work with for photosynthesis. So then I would say the number of leaves on the plant will, also going to say increase here. And then I have to have my because of science. And I'm going to say because water is required for photosynthesis. Okay, so this means that I've basically come up with a good science reason. Wow, I guess I'm really bad at spelling on the computer. I've gotten a good reason for this to be true. So I'm going to look at my data table now. Let's say I do this experiment. Let's say the number of leaves here is going to be 0 because the plant died. Okay, then my plant B, which I'm giving 50 milliliters of water, is going to grow 25 leaves. The one that I'm giving 100 milliliters of water is going to grow 78 leaves, and I'm just totally making these numbers up. I really am. And then the number on D, which is getting 150 milliliters, is going to be 85. Okay, so, or 80, let's do 83 because I haven't put a 3 yet. So if this was our data that we collected after we did this experiment, the thing we'd have to do after that is revisit our hypothesis. And this is something I definitely want you to write down. Hypotheses, so write this down. Hypotheses are not right or wrong. They are supported or rejected by the data. Hypotheses are not right or wrong. They are supported or rejected by the data, period. There's one more thing that could happen when you're writing your conclusion. Let's say that our experiment goes really wrong. We find out that there was a cat that knocked over our plants and pooped in the soil that is on the floor, and like our experiment just totally got messed up. In that case, when we revisit our hypothesis, we don't really know if the water helped or not. So here's one last thing to write down for this set of notes. Sometimes the data is inconclusive if there is experimental error. Sometimes the data is inconclusive if there is experimental error. And really, experimental error is what the controlled experiment is trying to get rid of, but it's still going to happen sometimes. Like we be in the lab, something goes wrong, and I'm like, why is this happening? Like I know it should happen a certain way because I've done the experiment a ton of times with students. And then I have to figure out like, oh, well, so and so was shaking the desk that the penny was on, and that's why it kept falling when it wasn't supposed to. Like, there's always a reason for it to happen, and so there's no wrong way to have an experiment. Even if you figure out that you were right, like, right, your hypothesis is supported, you still have to do more research. And a lot of times in science, when something is wrong, when our hypothesis is rejected, we still learn something really important. So don't worry, don't be afraid of your data, don't be afraid of what you get as your answers, just write down what actually happened. Scientists are always about the truth, except for a few times there's like some scientists who lie, but for the most part, we're about the truth. We want to find what's actually happening and why it's happening. All right, sorry that was a long thing in notes, guys, but I hope you have a great day. I know this is 21 minutes and 52 seconds so far, but if we did this in real class, it would be like way longer. So I guess this is actually a break. Have a good day.